is Dr. D. Govardhan, Professor and Dean, Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, we are discussing heat exchangers in heat and mass transfer. Heat exchanger may be defined as an equipment or the device which transfer the energy from the hot fluid to the cold fluid with a maximum rate, with a minimum investment and running cost. Here, if you take this figure now, the heat is exchanging from one fluid, this which is represented here now, in color, higher temperature. Yes, it is entering at one side. There now, this heat energy possessed by the hot fluid is transferred to the fluid which is flowing through the tubes which are inserted in it now. That is here now. Yes, it is there now, entering now and leaving at the other side. That is here inlet and outlet it is there now. In this case, the heat energy which is possessing that hot fluid is transferred to the fluid which is having at a lower temperature. In the heat exchanger, the temperature of each fluid changes as it passes through the exchangers. Hence, the temperature of the dividing wall between the fluids also changes along the length of the exchangers. The main examples for the heat exchangers are intercoolers and preheaters. These intercoolers and preheaters are generally used in turbines, regenerators, condensers, and boilers which are used in steam power plants. Oil cooler of heat exchange. Generally, these are used in automobile engineering, milk chiller and pasteurizing plant. Several other industrial applications, particularly in chemical industries also, they are used. There are several types of heat exchangers that are developed and they are classified is based on nature of heat exchanging process, relative directions of the fluid motions, because the fluid may be just moves both hot fluid as well as the cold fluid. They may move in one direction that parallel to each other, that is called here parallel flow, or they may move in opposite directions, so counter flow, and mixing is also taking place now. Design and constructional features, and the fourth one is physical state of fluids now. So these are the main just four categories that each segment are classified just based on. One is the heat exchange, relative directions, design and constructional features, and the physical state. Okay, first one, nature of heat exchanging process. That each heat exchanger on the basis of nature of heat exchange process, they are classified as direct contact heat exchangers, indirect contact heat exchangers. This indirect contact heat exchangers, they are classified again further two types, regenerators and recuperators. Direct contact heat exchangers. In a direct contact or the open heat exchanger, the exchange of heat takes place by direct mixing of hot and cold fluids, and transfer of heat takes place simultaneously. Here, the best example is, in order to heat the water at a certain temperature, the cold water as well as the steam both are mixed together at a time now. Hence, the latent heat possessed by the steam, that is transferred to the cold water, and the cold water temperature raises when it is leaving that container. In that case, the fumes which are generally non-condensable fumes which are generated, that can be escaped through the outlet that is provided. Here the purpose is in order to increase the outlet temperature of the fluid. Generally, the steam as well as the cold water, they are mixing together now. This type of heat exchanging between the two fluids is called direct contact heat exchangers. The best example for the direct contact heat exchangers are cooling towers, jet condenser, and direct contact to feed heaters. Here the figure 1 here representing a direct contact heat exchangers in which the steam mixes with the cold water. Here, in this case, hot water inlet is there now, cold water inlet is also there now. Here, the latent heat processed by the hot water, that is the steam, it is taken by the cold water. And in order to achieve uniform temperature, generally the stirrer also provided there. Hot water and non-condensable gases leave the container as shown in figure. Here note, a cooling water is a specialized heat exchanger in which air and water are brought in direct contact with each other in order to reduce the water temperatures. In indirect contact heat exchangers. In this type of heat exchangers, the heat transfers between the two fluids can be carried out by the transmission through which these two fluids are separated. Here the best example is there now. Hot fluid is entering from this position now, entering and leaving at other position now. That is the cold fluid here. Out it is there. Here, cold fluid is nothing but in, out fluid is the out position is there now. That is here this nothing but fluid 1 is there now, hot fluid now, and hot fluid, cold fluid out now. Here cold fluid in now is the 2 and 2 now. That is in this case the heat energy is transferring from the hot fluid to the cold fluid. These two fluids are not contact mixing with each other. These two fluids are separated by the boundary. Here the example for the indirect contact heat exchangers are regenerators, recuperators, or surface exchangers. Regenerators. In regenerator type of heat exchanger, the hot and cold fluids pass alternatively through a space containing solid particles which are called air matrix. This particle providing alternatively a sink and source for the heat flow now. Here as shown in figure now, it consists of here the outlets as well as the inlet for the cold fluid as well as the hot fluid. This container also consists of that matrix which consists of solid particles which is having high thermal conductivity. When the hot fluid is entering into the container which consists of solid matrix, it extracts the heat energy from the hot fluid, and alternatively when the cold fluid is entering into the container, the heat energy possessed by this matrix, that is solid particles, it gives out to the cold fluid. The means here now, the heat is exchanging from the hot fluid to the cold fluid without having any physical contact with each other. Here the examples for the regenerators now, IC engines and gas turbines, open earth and glass melting furnaces, air heaters and blast furnaces. These are some of the examples for the regenerators. Here one more it is there now. Here hot fluid is just entering just here one. That is inlet, hot fluid. Here hot fluid is going out here now. It is out position now. Here cold fluid is entering now, and the cold fluid is out now. That is the outlet. it is inlet. Here, according to this figure now, when the hot temperature fluid is entering into the container, here now, having its maximum temperature, but inside the container it consists of a shell or the tube in which cold fluid is flowing. Hence, when the heat, here these two fluids are separated by a shell which is having a thermal conductivity. Hence, the heat energy from the hot fluid is exchanged to the cold fluid just when it is moving along the length of the shell. This type of heat exchangers is called here regenerators. It is an example for the indirect contact heat exchangers. The advantage of here indirect heat exchangers, higher heat transfer coefficient it is there, less weight per kilowatt of the plant, minimum pressure loss, quick response to load variation, small bulk weight, efficiency is quite high now. Here disadvantage, when comparing with the direct heat exchangers, the cost involved is very high, and sometimes the leakage is also the main trouble in the indirect contact heat exchangers. Okay, recuperators. It is the heat exchangers in which the flowing fluids exchanging heat are on the other side of the dividing wall in the form of pipes or the tubes generally. These heat exchangers are used when two fluids cannot be allowed to mix, when the mixing is undesirable. Here, in this case, the fluid is nothing but here in this case it is representing the hot fluid is going now. Here hot is inlet, hot fluid, it is outlet, it is there. Here again the two tubes are kept inside it now. Here two more now. These are nothing but here entering now. These two fluids in these two pipes which are not desirable to mix with each other. In this case, the heat energy which is flowing in the center tube, that is called here now hot fluid now. The heat energy is dissipated or transferred from the hot fluid to the cold fluids which are present in the remaining two tubes. These fluids may be here different which are not required to mix with each other, not desirable now. So, the recuperators are generally used to heat the cold fluids of different types just by using single source of hot fluids. The example for the recuperators, automobile radiators, oil coolers, intercoolers, air preheaters, economizers, superheaters, condensers, surface feed waters of a steam power plant, milk chiller of a pasteurizing plant, evaporator of a nice plant. Okay, these are some of the examples for the heat exchangers. The main advantage is easy construction, more economical, more surface area for heat transfer, much suitable for the stationary plants. The disadvantages of recuperators are less heat transfer coefficient, less generating capacity, and shooting problems. Since these two liquids which are here heating, according to the system, their mixing is not desirable. Hence, the leakage problem is also more, and a maintenance cost involved in that case very high. Okay, classification of heat exchangers based on the direction of fluid motions. The fluids, one is in hot conditions, one more is cool. Here, according to this exchanger, the heat energy should be transferred from hot fluid to the cold fluids. But the direction of fluids, depending on direction of fluids, these exchangers are classified as parallel flow, or it is also called unidirections. That means the hot fluid as well as the cold fluid both move in the same directions. The second one is the counterflow directions. Counterflow means here both are moving in opposite directions, and a cross flow. These are nothing but just three types of heat exchangers are there. These are divided basically in the direction of flow of hot and cold fluids. The first one is parallel flow heat exchangers. Okay, in these exchangers, both the hot fluid as well as the cold fluid both are moving in the same directions. The two streams enter at one end and leaves at the other end. The temperature difference between the hot and cold fluids goes on decreasing from inlet to outlet. Here, I am taking here the example now. Here cold water is there now. Here fluid is entering one side now. All fluid also entering in the same direction. So, both are moving in the same directions. According to the figure, they are moving from left to right to left directions. Here, the temperature possessed by the hot fluid, it may be just assume just 70 degrees is there, and the cold fluid is here it is equal to maybe just room temperature 30. But when it is moving this other directions, almost the difference between the temperature of hot fluid and cold fluid is just decreases. Here it is maybe just 40 it is there now, 70 minus 30. The difference between the hot and cold fluid when they are entering, but while leaving, almost the temperature possessed by the hot fluid as well as the cold fluid both are same now. Or this figure is representing here T in nothing but representing temperature of cool fluid, lower temperature. Here TH is representing the temperature possessed by the hot fluid. AB is representing assume just length of the pipe, just nothing but it is the length in which these two fluids travel now. As moving from A to B now, the temperature of the cold fluid gradually increases now. The temperature of the hot fluid gradually decreases. So, here the temperature difference is maximum at the inlet, but while leaving, the temperature difference is almost 0 or the minimum value there now. Okay, this type of flow is called parallel flow exchangers. The disadvantage of parallel flow exchangers, that is, it needs a large area and generally not used in the practice. The example for the parallel flow exchangers, oil coolers, oil heaters, water heaters, and these are also called parallel flow creek operators or the surface heat exchangers. A counter flow heat exchangers. The name itself representing the cold fluid as well as the hot fluids. Both are moving in opposite directions in a container. So, the heat energy is transferring from hot fluid to cold fluid. Here, and here it is taking this is nothing but assume this here now external pipe it is there. Here cold fluid is entering from the left to and leaving it towards the right side, but hot fluid is entering from the right and moving towards the left side. In this case, the maximum amount of heat energy that is extracted from the hot fluid into the cold fluid when comparing with the parallel flow heat exchangers. The temperature difference between these fluids remains more or less nearly the constant because both are moving now in opposite directions. This type of heat exchangers due to counterflow gives a maximum rate of heat transfers for the given surface area. Hence, such a type of heat exchangers are most favorable for heating and cooling the fluids when comparing with the parallel flow heat exchangers. Here, this graph is representing here now. The y-axis is representing temperature of the fluids. Here, both are moving in opposite directions now. This is the treated as the just inlet for the cold fluid now. Here it is moving toward the right side to left side now. Hot fluid is there now. The temperature is here. It is the TH maximum value moving in toward the left side to right side. Hence, while moving now, the temperature difference at the inlet as well as that is nothing but at the both ends almost the same now. This is the most favorable practice for transferring heat energy from the hot fluid to the cold fluid. Here class flow. In class flow, the heat exchanger, the two fluids, that is hot and cold fluids, cross one another in a space, usually at right angles now. So in previous cases, maybe here a counter flow or parallel flow, the two fluids, they are moving parallel to each other. That heat energy is transferring from hot to fluid to cold fluid when they are moving along the path. But in this case, these two fluids are moving perpendicular to each other now. The figure number A5 shows the schematic diagram of common arrangement of cross flow heat exchangers. Here, it is in this case, hot fluid is entering now. It is moving from left hand side toward the right side, as shown in figure. But at angle of 90 degrees now, here cold water is entering now. That cold fluid is entering and leaving from the top to bottom position. Approximately the flow, the direction of flow of hot fluid as well as the cold fluid both are perpendicular to each other now. The hot fluid flows in the separated tubes and there is no mixing of hot and cold fluids now. The cold fluid is perfectly mixed as it flows through the heat exchangers. The temperature of this mixed flow will be uniform across any section and will vary only in the direction of the flow now. The best examples for the cross flow are cooling unit of refrigeration system and automobile radiators. Okay, based on design and construction features, the heat exchangers are classified as here concentric tubes, just as shown in figure. Okay, in this case, the two tubes which are carrying at as well as the cold fluids, both are arranged concentrically with each other. In this type, two concentric tubes are used for carrying the fluids. The direction of flow may be parallel or may be the counter. The effectiveness of the heat exchanger is increased by using swirling flow also now. So in this case now, here TW1 is representing the just temperature of the hot fluid now, and T1 cold fluids. Here both are nothing but here moving in the same directions. Here according to this figure, here TWT is representing the second temperature of the hot fluid, TCT representing the temperature of the cold fluid now. Here these fluids may be just move in the same directions. Here only the difference because of the construction features. Both the tubes, one is the larger, one more is the smaller, which are concentric axis. The concentric tubes that are made to carry the hot and cold fluids, and it is a more effective and compact area. These fluids may be move in the same directions, that is parallel, or it may be the opposite directions, counter flow, or it may be swirling, that is taking place, that more amount of energy that can be extracted. Shell and tube now. In this type of heat exchanger, one of the fluids flow through a bundle of tubes, enclosing by shell as shown in figure now. Here the difference between the previous one, it is called concentric tubes now. It carrying only two tubes now. But in the case of shell and tubes now, the shell is treated as just an outer tube now, which is here carrying hot fluid. It consists of the number of inner tubes are included in it now. When the fluid is flowing, is through it maybe in a clockwise direction, in a parallel direction or counterclockwise direction, the heat exchange is taking place, transfer is taking place. So in this case, the shell is consists of large number of tubes just inside it now. The outer fluid is forced through the shell and it flows over the outside of the tube. So such arrangement is employed where reliability and heat transfer effectiveness are more important. Here multiple shell and tube passes now. In the previous case, just one shell is there, it carries number of tubes. But in this case, it consists of multiple shell and tubes as shown in figure are used for enhancing overall heat transfer now. The multiple shell process is possible where the fluid is flowing through the shell is rerouted. A compact heat exchangers now. In order to increase the rate of heat transfer, sometimes small projections are also kept this inside it now, the tubes, in order to increase the rate of heat transfers. These are called, these projections called plate fin or flattened fin tubes exchangers. Here these are the special purpose heat exchangers. Very large heat transfer per unit area taking place by using compact heat exchangers. They are generally employed when convective heat transfer coefficients is associated with the one of the fluid is much smaller than the associated with the other fluids now. So generally it is having projections which are called here fins now. And depending on just the physical state of fluids, these exchangers are classified into condensers as well as the evaporators. It is one of the heat exchanger process in which, based on the physical state of the fluids which is carrying, they are classified as condensers as well as the evaporators. Here in a condenser now, the condensing fluids remains constant. The temperature throughout the exchanger, while the temperature of the cooler fluid is gradually increases from the inlet to outlet. Here it consists of two fluids now. One is the cold fluids, one more is the other fluid now, cold hot fluid now. The temperature of the one of the fluids that remains constant now. Other fluids temperature gradually increases when the fluid is flowing now. In this case, the latent heat possessed by the one fluid that is extracted by the cold fluids, hence the temperature is increases now. And this is called condenser now. The second one is evaporator now. The hot fluid loses the latent heat part of it which is accepted by the cold fluid. The temperature distribution is the condenser is shown in a figure now. In the evaporator now, the boiling fluid remains at constant temperature, while other temperature of hot fluid gradually decreases from the inlet to outlet now. Here, this temperature is a constant here now. The boiling fluid temperature remains constant. The other fluid it is there when it is moving now. Here, the temperature here increases from the inlet to outlet when it is passing through it now. That is, in previous case, the condensation process, the temperature of the fluid, the hot fluid is constant, but latent heat possessed by the that fluid, it is extracted by the other body, so that the temperature increases now. In the evaporator, that is the hot fluid is in the form of vapor, that latent it processed by the that is the hot fluid, that is used to heat the fluid which is processing at a lower temperature. So these are nothing but representing the diagrams for the explanation of how the temperature is transfer is taking place is shown in figure now. So the summary is now, in the case of condensers now, the temperature nothing but here now gradually this increases now by taking latent heat of hot fluid. In the case of evaporator, the temperature processed by the higher body that remains constant, that latent heat processed by it is taken by the cold fluid in order to reach its temperature. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.